Good day everyone. Today I will be discussing the topic that I have chosen, which is density-based clustering and how it works. So we will start in knowing what's the definition of density-based clustering. So density-based clustering refers to unsupervised machine learning methods that identify distinctive clusters in the data, based on the idea that a cluster or group in a data space is a contiguous region of high point density, so separated from other clusters by sparse and region. So how density-based clustering works. So in this topic, the density-based clustering tools works by detecting areas where points are connected and where they are separated by areas that are empty or sparse. So points that are not part of a cluster are labeled as noise. So optionally, the time of the points can be used finds groups of points that cluster together in space and time. So this tool uses unsupervised machine learning clustering algorithms which automatically detect patterns based purely on spatial location. So in the distance to a specified number of neighbors. So these algorithms are considered unsupervised because they do not require any training on what it means to be a cluster. So here are just some ways that density-based clustering can apply. So the first one is in urban water supply networks are important hidden underground assets. So the clustering of pipe ruptures and bursting can indicate looming problems. So using the density clustering tool, an engineer can find where these clusters are and take preemptive action on high danger zones within water supply networks. The other one is, suppose you have position data for all successful and unsuccessful shots for NBA players. So the density-based clustering tool can show you different patterns of successful versus failed shots position for each player. So this information can then be used to inform game new strategy. Base clustering algorithm, or also known as DBSCAN, has two hyperparameters, the epsilon and the neighbor. So epsilon is a distance measure that will be used to locate the points and to check the density in the neighborhood of any point. So as you can see at the illustration, so there is a there is a center point and the epsilon inside the circle, which is inside the circle there's 6 and that will be the neighbors. Density-based clustering issues. So the first one, some points are not assigned to a cluster. So good or bad depending on the application. So ambiguity or non-core boundary points. And the second one is sensitive to the choice of epsilon and minimum neighbors. Otherwise, non-sensitive to initialization except for boundary points. So if you get a new example, finding cluster is expensive. Need to compute distances to training points, and in high dimensions need a lot of points to fill the space. So this will be the end of my video presentation. Thank you and sorry for the barriers.